Our next experiment is called the quantum leap of science, or glow in the dark. We are going to be using a special powder called zinc sulfide to make things glow. This is a great little kit from our friends at the Universe of Science, and they have done a great job with their explanation of how this all works. And all you really have in this baggie is one little bottle, which you might notice I've taken the cap off. And the reason I took the cap off was so that it would be under the light. When light hits this chemical, something happens. And what happens is it absorbs that light energy in the form of little tiny particles called photons. And that super excites it and causes it to glow in the dark. Nearly everything that you see that glows in the dark through this way uses this chemical. Not everything, but nearly everything. This is called phosphorescence, and it has to do with light being emitted, then absorbed, and then radiated out. So what are we going to do today with our phosphorescent experiment of science? Well, first I want to tell you a little bit more about this chemical. This chemical is called zinc sulfide, and it forms when different elements combine. We have the element zinc, Zn. Zn is its symbol on the periodic table. S is sulfur, and then ZnS is zinc sulfide. And this arrow is read as yield. And we'll talk more about that as we go too. But in math, you might have 2 plus 2 equals 4. In chemistry, we have element plus element yields something new and different than what we started with. And this, ZnS, is a compound. So here we go. When zinc and sulfur meet, they create this yellow product here. And what I'm going to do next is I'm going to pour some of it in here so that you can see it. And I'm going to pick up our camera. Right now, light is hitting the yellow chemical. And this is a very important step here, because what we have here is a chemical that something is happening that you can't see. It is absorbing light energy. In the vial, there are billions and billions of very small atoms of ink and sulfur. Each atom is made of smaller basic building blocks called protons, neutrons, and electrons. And those building blocks make up atoms. The electrons are in orbits around the center or nucleus, which contain the protons and neutrons. And it is the electrons that that is responsible for anything that glows. It is the electrons in the atoms of the glow powder that absorbs the light energy and causes it to glow. Electrons exist in different orbits in the atom. Each orbit has a different energy level. The orbits farther away from the nucleus have higher energy levels. The theory that the electrons jump to higher levels, or an excited state when they absorb energy. Light energy is in the form of photons, or small quantities. The electrons then give off or emit photons as they return to their normal state in the atom. The amount of energy is called a quantum, and the electrons must take a quantum leap, and that's the name of our kit, to be able to glow. For electrons in atoms, the quantum leap is like a step up on a stairway, and a photon of the right energy must be available for the electron to absorb and to jump. This theory that we're talking about relates to a very famous scientist named Albert Einstein. Einstein showed that light can also appear to travel and act as a particle. Einstein gave the name photon to a single quantum or particle of light energy. Einstein's famous equation, E equals mc squared, shows the fundamental relationship between energy, matter or mass, and light. Light looks like a continuous beam, but is made of small individual particles called photons. In fact, everything, when looked at on a smaller and smaller level, becomes discontinuous or made of small, separate or discrete units. Every physical quantity must ultimately be composed of an elementary quanta. Einstein gave an example that we can weigh large quantities or tons of sand and regard its mass as continuous. But on the small scale, the mass could change only by a multiple of 1 grain of sand. And that would be the most precise measurement. Each grain is slightly different. That it is also the limit of our certainty about its measurement. A photon of yellow light is different from a photon of blue light. They have a different frequency and energy. The electrons in atoms, a photon of the right energy, must be available for the electron to jump, to absorb and jump up to the excited state. The next experiment will show this. The quantum theory and Einstein's other theories on relativity have opened up strange new chapters in physics. The beautiful glow in the glow powder is a simple bit of evidence for the quantum. But the theory also leads to quarks and fundamental particles of matter and creation itself.